Assalamualaikum and good morning to Sir Farquhar. So today I will explain about lab 6. So this is how I place my component, which is consists of DC voltage, switch, resistor, but there are no emitter in Multisim Live. So I chain it with current probe and then I put another ground. So for table 1, we just need to remain the value of resistor, but we need to change the value of DC voltage. So for example, if I set the DC voltage as 3 volt and then I run the simulation, I will get the 15 milliampere, and this is the result that I should record in the table. And then for the next step, I just need to change the value of voltage in the DC voltage, and I need to record the result that I got from here. Okay, so for table 2, I still use the same placement that I used for table 1. Just for table 2, I need to change the value of resistor, but remain the same the value of DC voltage, which is when I run the simulation, the result that I got from the circuit is the one that I need to record for table 2. And then the next step is I need to change the value of resistor to 100 ohm, 1000 ohm, 4700 ohm, and 10,000 ohm. And for calculation, we can use the formula of V equal to IR, and then we can find the current. So this is what I got for the both table from the simulation. And then for the graph, this is what I got for both graph, which is for graph voltage versus current intensity. I got that current intensity is directly proportional to voltage, which is when the voltage is increased, current intensity also will increase. And then for second graph, which is current versus resistance, it shows that current intensity is inversely proportional to resistance, which is when the resistance is increased, current intensity will decrease. So this is what I got.
Okay, Assalamualaikum. My name is Airul bin Abdul Sani from Group 30. Is going to present on lab sheet, which is about Ohm's law using Multisim simulation. Okay, for the procedure, we need to set up the circuit as shown as figure 1 and set Rx value as 200 ohms. And then raise the voltage from the power supply 3 up to 12 volt and record the measure value for current intensity in table. As you can see, this is the circuit that I set up. You can see this resistor value is 200 ohm and power supply is 3 volt. When I click run, I'm sorry, I use the current probe, then I click run. So you can see the current intensity in the circuit is 15 milliamps. Then when I change the voltage to 12, and when I click run, as you can see, the current intensity is 60,000 milliamps. This is the data that I got from table 1. This is the result. As you can see, from the simulation, I got this result, and for the theoretical, I using the Ohm's law, which is V equal to IR. So if we want to find the I in this. If we want to find I for this table, we need to use I equal to V per R. Okay, for the table 2, we need to set the voltage to 5 volt, and we need to change the value of the resistor for each part. So we need to change to 5 volt, and we need to change to 68 ohms. When I click run, as you can see, the current intensity in the circuit is 73.529 milliampere. So when I change the value of 10,000, when I click run, as you can see, the value is 500 microampere. This is for the rest resistance value. This is I got from the table 2, the result and data. For theoretical, I use using Ohm's law too. For the graph, as you can see, the graph is linear, which is straight line. As you can see, when the voltage is increased, the current will increase also. For the table 2, this is the current versus resistance graph. As you can see, when resistor decrease, the current will increase. That's all for my presentation.